Starting with the first word problem, the sum of twice one number and 3 times another is 41. If the second is subtracted from the first, the difference is 8. What are the numbers? So let's look and see at what our important information is. Here, I'll highlight it. The sum of twice one number, 3 times another, is 41. If the second is subtracted from the first, the difference is 8. And in green, what are the numbers? So, from here, we have a couple of equations. We don't know what our two numbers are. That's what we're looking for. So let's label them x and y. The sum of twice one number, 2x, and 3 times another is 41. If the second number is subtracted from the first, we get a difference of 8. Now all we need to do is solve for x and y. In this case, I would say that we can multiply the bottom equation by 3 and use a linear combination. So we get 2x plus 3y equals 41. And 3x minus 3y equals 24. Our goal here is so that when we can add our two equations together, we can cancel out one of our variables. If we add these together, 2x plus 3x is 5x, 3y minus 3y is 0, and 41 plus 24 is 65. Now, if we divide both sides by 5, we find that x is equal to 13. We take this number and plug it back into one of our original equations. The bottom one would be easier than the first one, so I'm going to plug my 13 in for x here and get 13 minus y equals 8. Subtract 13 from both sides. Negative y equals 5. Sorry, negative 5. Y equals 5. So our first number is 13, and our second number is 5. The second word problem is twice Lisa's age is 11 more than Jessica's age. The sum of Lisa's age and twice Jessica's age is 43. How old are the girls? So again, highlight the important information. Twice Lisa's age, 11 more than Jessica's age. Sum of Lisa's age and twice Jessica's age is 43. And in green, we're going to highlight what we're looking for again. How old are the girls? So, we are looking for how old these girls are. In order to do this, we're going to need variables because we do not know what their ages are. So we're going to say L is Lisa's age, and J is Jessica's age. So our first sentence says twice Lisa's age is 11 more than Jessica's age. So that would be Jessica's age plus 11. Our second equation, the sum of Lisa's age and twice Jessica's age is 43. These are our two equations. We now have a system of linear equations, so now we just solve. If we solve these, we can rewrite our first equation such that we're solving for j. 2l minus 11 equals j. I can take this value for j that I've just found, 2l minus 11, and plug it into my second equation. So I have l plus 2 times 2l minus 11 equals 43. From here, we can distribute our 2 amongst our two terms. L plus 4l minus 22 equals 43. Now combining like terms, 4l plus l gives me 5l. Add 22 to both sides. Again, we get 65. This looks familiar from the last problem. Once we solve this out, L equals 13. So we know Lisa's age is 13. Now we can figure out Jessica's age by plugging Lisa's age back into one of our equations. I'm going to use the blue equation here to simplify my process. 2 times 13 minus 11 equals Jessica's age. 2 times 13 is 26, minus 11 is Jessica's age. 26 minus 11 is 15. So Jessica's age is 15, and Lisa's age is 13. Here we have our third word problem. 14 cans of pet food cost $9.60. If the cat food costs 60 cents a can, and the dog food costs 75 cents a can, how many cans of each were purchased? So here we look at the information we have. We know we have 14 cans of food altogether. We know that they cost $9.60. If the cat food costs 60 cents per can, dog food is 75 cents per can. How many of the cans were purchased? So we're looking for how many cans of each were purchased. Our two equations in this point. We don't know what our variables are, so we can say C for number of cans of cat food, and we can say D for number of dog food. From here, we know that we have 14 cans total, and in order to write our equation as total cans, number of cans of cat food plus number of cans of dog food gives me 14 cans total. We know that this costs $9.60. The total value of my cat food is 60 cents per can, and for my dog food is 75 cents per can. So I have C plus D equals 14, and 0.6C plus 0.75D equals $9.60. From here, since I have coefficients of 1 on C and D up here on the first equation, I'm going to use substitution. I'm going to rewrite my first equation as C equals 14 minus D, and plug that into my second equation. This way I'm not multiplying by decimals or getting really weird numbers when I'm trying to do the linear combination method. So we get 0.6 times 14 minus D plus 0.75 D equals 960. From here, once again, I'm going to distribute amongst the parentheses. 0.6 times 14 turns out to be 8.4. Minus 0.6D plus 0.75D equals 960. I now need to combine like terms. 0.75D minus 0.6D gives me 0.15D, and that's equal to, if I subtract my 8.4 from both sides, we see that that is actually equal to 1.2. If I solve this out by dividing both sides by 0.15, turns out D equals 8. If D equals 8, C obviously equals 14 minus 8. 14 minus 8 is 6, so C equals 6. Therefore, 8 cans of dog food were purchased and 6 cans of cat food.